here we go. All right, who can tell me what the limit as we approach infinity of sine of x over x is? 1. 0 or 1? Which one? I think you're wrong too. It's 0.
Only one.
Remember, that's the graph. If you need a visual, it does this business. Remember, it does that really. You look at it, does it do this? Yeah. Get the sound on. Okay, so that's 0, and negative infinity then would be the same thing because it's a symmetrical looking thing. All right, now when we approach 0 here, that's 1, right? And then this one isn't that common, but it does come up occasionally. This is the same as this, but these three are, ones that you want to keep in the back of your head. I'm not sure why I left that whole page blank, but let's move on. Okay, now this is something I'm using to find the derivative of sine. I'm using the definition. Now, unless you forget what the derivative of sine is, you shall never have to do this ever. Okay? But there is going to be a lot of things that you're going to have to remember just blankly. And we talked about the derivative of sine coming up. It came up on one of the lessons already, remember? And did you remember it? What it was? Nobody remembers? Let me see if I can find it here real quick. We talked about it. I'm trying to figure out which. Never mind. We'll just go through and figure it out. Okay. So sine of x now becomes sine of x plus h, because that's the f of x plus h minus sine of x over h. Okay. This right here is not a distribution. I know you're going to think it is, but that's that one identity, that's some identity from pre-calc. Okay. Then we regrouped. This and this are now that. We're just regrouping because we are now dividing up. The h came over this piece, so we're grouping again. Okay, and then we are taking limits separately. So we took a limit there, we took a limit there, we took a limit there, and we took a limit there. Remember, the limit of a product is the product of the limits. So that's we made that a little bit. And then this is one that we're supposed to know. That's where the 0 comes from. That's one we're supposed to know, except with an h in it. So that's the same idea. And then we have two, well, anything times 0, 0, right? So really we have one left. What is the cosine of 0? It is 1, but we don't have any h. So the limit as h approaches 0 of cosine is cosine. So bottom line, derivative of sine is what? Cosine. Okay? All right, that's the bottom line. Now, like I said, unless you forget how to do what the derivative of sine is, you never have to do that again. But honestly, at this level, I think it's important for you to know where things come from, not just like from the air. Now, we're just going to do the other ones from the air. Hello, I don't want you, what are you doing? Okay. All right, so these are the ones you're just going to have to remember. All right, cosine of x. Anybody have a hardback book? Nope. Nobody has a hardback book? Not with you. Okay, I'm going to just show you where this all is in case. It's a nice, okay. Does anybody remember when it came up what the derivative of cosine was? Negative something, yes. Negative sign, very good. Okay. Now, these are grouped in this way for a reason. If you have a hardback book, you have, I know this is one of the 10 most famous words, most beautiful words, a flap in the back. These hard cardstock on this page, and that's what I want to copy for you, are the derivatives that you'll need to know. We don't need to know. We're going to go to there. We don't do the hyperbolic ones. Okay. So tangent of x is secant squared of x. Okay. Secant is secant tangent. Okay. These are all in the book. Yes.
Are our choices the ones?
What?
Are our choices?
Oh, sorry. Yes. All right. So we have two left, right? And notice that they're both negative. The two that are left. Okay. Any guesses to what cotangent, the derivative of cotangent is? Cosecant squared? Yes. And then negative cosecant cotangent. Okay. All right. So I got my x over here. We don't want to do that. All right. Now, please tell me why I might have grouped them in that way and how I'm going to remember. Yes, there is a lot. There's 6 to remember. But how am I going to remember if they're negative or positive? The big column that's negative. Okay, they're all the co's. All the co's have negative derivatives. Cosine, cotangent, cosecant. Okay, all the regular ones, sine, tangent, secant, have positive derivatives. Okay, now this will help you with the rest of the memorization. But y'all got good memories, right? More so than me. I can remember them. Anybody can remember them. Oh wow. Okay, on this, remember, sine and cosine functions are differentiable for all x's. I don't know if you can read that. Let's just write it. Sine, cosine functions are differentiable for all x's. The other functions have limits. And I mean that not as in the limit as blah, 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 but you're limited on your domain, okay? So just in case that shows up, sometimes they tell you that up front, and sometimes they assume that you know that. Remember, for tangent, remember tangent goes like this. Okay, so at every hip stitch, like right here, we don't have a value, so of course we're going to have a tangent value. Okay, so you're going to have some domain issues of, you know, the tangent at what point would this be? 5 or 2 would not exist. Okay, so you're going to have some of those values simply because of the nature of the graphs or the domains, however you want to look at it. Okay, so you're going to memorize these, and then we're going to start applying them. Okay, now I'm trying to use all the different language that we know, so I'm not just sticking with y prime. We're going to see dy dx. What's the derivative for second? So for derivative, I could call it y prime, I could call it f prime, I could call it d dx of whatever, I could call it dy dx. Okay, so you're going to see all those names. All right, what about for the second derivative? What do I got to call that? Besides y double prime and f double prime, what's another name for the second derivative? Remember I told you last year they were like, I don't know what that is. It might have been the year before, honestly. Remember what the second derivative name is? Okay, well, hopefully it'll show up today. All right, y prime. I don't want to, y'all aren't exercising your memories very good. For an old woman, I'm beating you here. All right, what am I going to do to find y prime? 2 words. What is rule? Product rule. Okay. All right, so, Allie Prevey, tell me how this is going to work.
X squared, or
Prime of x squared, good.
sine x.
Good. What did you say? Did you say minus?
I'm thinking
You meant plus, right?
plus X squared prime cosine X.
Very good. Okay. All right, that's the product rule. All right, take it from there, Hannah.
From there, it's 2x sine of x plus x squared cosine of x.
Very good. Oops. Okay. Now, I'm finished with that. Because I'm not doing with it, add anything else with it, I don't feel the need to factor it. If you feel the need to factor, how would it be factored? X times 2 sine of x plus x cosine of x. Okay, it is very pointless if you're not doing with anything with it, but eventually we're going to get it equal to 0, and then we will want the factors. So, but yeah, right now this is totally sufficient. Okay. All right, that's it. Y double prime. If y equals secant. Okay. Now y prime. Secant theta, you cannot say, I don't like theta, so I'm going to use x. Please don't use x. You're smart enough, you can keep theta. So when you are looking for secant x, here's your derivative, and you just replace it with the theta. So okay, there's y prime. It's a memorized definition. All right, now, y double prime, you say, is going to involve what? Rule. Good. All right, go for it. Derivative. Good job. All right. What's the derivative of secant theta, Aaron? Okay. And that's that. Then we have another tangent theta. And then what's tangent theta derivative, Lindsay? Good job. Now, there is a better way to write this, even though we're not doing anything else. What would be the best way to write that, Abby? Yeah. Y'all are saying tan, but it's tangent, right?
Wait, no, you forgot.
Forget.
You forgot a tangent in the second part.
No, I didn't. This right here is this.
Oh, okay.
So that's good. That's your simplified. Now, you could factor it by taking out secant theta if you want. But, again, we're not doing anything with it. There's no point. Okay? So that's your second derivative. We're doing the same rules as you've had, except now you're putting some trig in there. All right, F prime again. Lots of trig going on. Guess what else is going to come up that hasn't come up? And since probably the summer assignment much. Unit circle values. All right. All right. What rule am I going to use, Sydney? Quotient rule. All right. Molly, go for it. Okay. Very good. What'd you say? Okay. In here, squared. Okay. All right. Take it from there, Emma.
Okay. Negative sine of x.
Good.
Sorry, plus sine of x. Minus cosine x. Times cosine x.
Very good.
Over.
Okay. All right. Okay, Allie. Simplify that top. Allie Rivers. Sine square of x, you mean? Okay. Okay. All right. There's a nice identity there. If there's, this is the one that comes up. There's not a whole lot. And I'll write it more obvious, but this one is nice. Remember that one? What is sine squared plus cosine squared?
You dropped your negative.
I did drop a negative. I dropped it right over here.
So,
So I took it out.
Yeah.
Okay?
I thought you already wrote the next part.
All right. So what's sine squared of x squared equals 1? So then this becomes 1 plus sine of x, quantity squared. Notice we left it in factor form all the way through the problem. And then we have what? Negative sine of x. What's left? Minus 1. Oh, wow. I should have left that factored. Then what? Negative 1 to me? Okay, very good. Okay, so it boils down to a nice, decent answer considering here's where we stopped with the derivative. So it turns out nice. So just that identity probably will show up. Okay, and then it's derivatives too. And by derivatives, I don't mean the derivatives, I mean, let's just talk about these real quick. Do you remember if we divide by sine squared? What's my other identity? 1 plus, what's that? Cotangent equals cosecant. Okay. Yes, these are your pre-cal ones. And then what's your other one? You divide by cosine squared equals secant squared. Good. Okay. So those three, 1, 2, 3, those will show up. Okay. The rest of them, there might be one more that'll show up, which is sine of 2x equals 2 sine of x cosine of x. That one shows up occasionally too. And if you recall, those are the ones, that was the one I had you memorize last year. Cosine 2x doesn't really show up. So anyway, and you know, you can always look those up if you have the hardback, which some of you don't. But anyway, okay. Any questions on what we did on that algebra there? Because from here really on, it was all algebra. We're all good? Okay. All right. Okay, good. Go get some whiteboards. We're going to do some practice. Do some derivatives. All right. And, okay, while you're doing that, I'm going to run and get some copies real quick of this. I'll give you a problem and then I'll run. It's one of the 10 most hated words. Wow. Yeah. Yeah. Right up there with noise. Oh. And what are some other ones? I don't want to penetrate. Yeah, exactly. Trying to go back. All right. Yeah, that's like bust through. Most of them are all right, I'm going to give you a good one to start, and then we're going to run this copy on your back. Okay.
Yes, yeah. I'm guessing.
Okay, so cosine is.
Yeah.
Oh, product listing only. Forget the product listing.
Well,
that was bust.
I thought you were going.
We just talked about we don't like the word bust, but.
Oh, sorry. That was a disaster. No puppies. Okay, are you done?
Yeah.
Alright, so Y prime, 5, negative sign. Use the product rule here?
Yeah.
Alright, good. Negative sign, sine, plus cosine, cosine. Right? Negative 5 sine x plus negative sine squared cosine squared. Is that what you got for Y prime?
Yes.
Right? And what's this mean? This is the one that, and we're still recording, this is the one that some of them didn't recognize that one year. All right, so Y double prime. This is the constant. I just pull it out, make it. Okay. Now, how am I going to do derivative of sine squared? How do I do that? For what? They have to both be negative for that to be -1.
my God, that's great.
Oh, it's not going.
That's right.
Me and Molly were like, oh, we got this.
Okay. So what do you do with negative sine squared as far as the derivative goes? Because it's no.
One minus cosine squared.
Would that help you? So first of all, this would be 1 minus sine squared. Do you want to do that?
Yeah.
You're still gonna have it squared though, right? Let's do it. Okay, so what would that give you? 1 minus 2 sine squared? That would probably be more helpful to what? Sorry. Okay, wait. One step at a time here. All right. I'm still on y prime. If you're deciding to do that, that's this minus 2 sine squared plus 1. Everybody look at that? Okay. So that's y prime. Okay. Now, y double prime, we can do that. Now, we still are in a quandary what to do about the sine squared. No. Yes, that's what we're going to have to do right now. This is where we're going next, but all right, so this is your product. Good job, Molly. Okay, so I got my -2. What's my derivative of -2 sine of x? Well, here, let me write it out. -2 sine of x, derivative sine of x, plus -2 sine of x, derivative of sine of x. What's the derivative of 1? 0, so we're good. Since we don't have any more. All right, here we go. Did I lose anybody? That's the product with the -5 cosine of x minus, I'm going to just clean this up and see what happens before I get rid of my brackets. Okay, what's the derivative of -2 sine of x? -2 cosine of x, good. Sine of x minus 2 sine of x. What's the derivative of sine of x? Cosine of x, right? Right?
Since you did minus plus, since you did -2.
That is a negative.
I know, but then minus our friend in general.
I haven't taken care of that yet.
I know, but why did you make a negative and then minus?
My -2 was with my sign.
I know.
So then you get plus a negative.
So the
2 side. Look at your work. Go up a little bit more.
this is what I'm differentiating, right?
Yeah.
That is what, that is that, right?
Yes, but we're saying, how come that it's a minus and a -2 shouldn't be plus the negative? No.
Oh,
Outside the road, outside.
right here?
Should that be
I haven't done that yet.
But shouldn't it be plus?
No. It's, oh, got it. You're right. I'm wrong. Okay, so you just, this should be plus. Okay. You are right. Okay, well that makes it easier. Ooh, sorry. Okay. So we could have left the negative and not put it in there. I get you. Okay. All right, so what is all that mess? It's the same thing, right? These are common, same terms. So how many is that? -4. Cosine of x, sine of x. Just kind of a hint, this is y double prime. When you have like a term that is that, if you write in the same, like maybe alphabetical, like xy instead of yx, you'll recognize that they're the same quicker than you won't. Okay? Like sometimes you don't recognize it if it's not written in the same way. All right, let me turn this thing off here.